Hi class, I want to introduce you to how to make data. This is called a reverse engineering technique where instead of using data that's already been provided to you, you are challenged to create a new data set with special nuances, situations, outliers perhaps, errors perhaps, anything that you've dealt with before. Okay? By doing this, it forces your brain to think about data construction as you're building new data sets. It forces you to think about those things that you've dealt with through studying statistics before. So I've got a data set here that I'm going to start developing. It's called Hockey Data Maker, and I'm going to go through a lot of the different situations that occur when making data. So the first thing first is I pulled a bunch of random names, first name and last name, and then I mashed them together. Okay. The second thing I did was I brought in hockey positions. So I've got all of these positions here, and I'm going to put a 1, 2, 3, 4 all the way down. And what I want you to see here is I repeated everything except for the goalie. Now, why did I do that? Because you only have one goalie on the team. You have two defense, two right, one center. In fact, I could go ahead and remove the center, the second center as well, so that it mimics the players on the team. Okay. What's going to happen here is when I do a random pull, and you'll see that in a moment, it's going to pull a 1 to 10 chance. So a goalie has a 1 in 10 chance, a right wing has a 1 in 5 chance, and vice versa, everyone else. The center also has a 1 in 10 because there's only one of them on the rink. So here's what we're going to do. We're going to do a VLOOKUP of rand between 1 and 10 because I have 10 numbers here, 1 through 10. And I'm going to grab all this, grab the second column, and pull it over. I'm going to bring it down. And now we have all of our positions. You see that right wing seems popular, left wing, right defense. And we have a few goalies, but not too many. We have not too many centers either. That's exactly what we want. So I'm going to copy, paste special value this, so now it doesn't change. Now, one thing I want you to note here is that I have introduced a problem in the data set. I have two people with the same name here and two up here. Now, this could be a situation where I particularly introduce errors in the data set so that I can train you as a student on how to deal with those errors. But in this case, I'm just going to get rid of that. I don't want to go too difficult here, ramp up that difficulty. I'm not going to try to introduce any errors here. So I'm going to delete those two folks there. And now we're down to here. Okay? I want you to note too that I have male and female based on sex. So just be mindful of that this isn't an all men's or all female data set as well. Now we've got student information here. Now, class, we could go with 1 through 4, or we can set up something else. So let's go here and put in class. What we're doing, by the way, is we're creating an index. So we're going to go 1, 2, 3, 4, and we will do fresh. Still call them freshmen. I wish there was another way we could call it. Sophomore, junior, senior. Okay. So now, with a similar principle to before, we can do a VLOOKUP. In this case, you have to ask yourself, and this is that reverse engineering piece, do you want all of these people to have a 1 in 4 chance of being a sophomore, a freshman, etc.? Or, just like we did before when we made this, where we duplicated this over here, to increase the probability of one of these being pulled as opposed to a goalie or center, we want to do the same thing here. Okay? So, for example, why don't we do that? Why don't we put a 5 and a 6 and copy junior and senior. So now our data set will have, so if we do this, so this one will have 1 equals 1 divided by 6, and this one will have 1 divided by 3, or 2 over 6. So these will have a 33% chance of pulling versus these here. And I've highlighted these here, and you scroll right over here, you see a 1 there, because probability needs to be 100, right? We set that up correctly. I just wanted to show you that it doesn't matter. I wanted to show you what we're doing here. So now we're going to do the same kind of thing. Look up rand between 1 through 6. We're going to go over to class, 2, 0, boom, Bob's your uncle. So long as you put the right number in. I put a 9 by accident, typo. Always put a 0 there, always put a 0 at the end. Okay, so now with height, this could be a situation where we have to think a little bit closer with unit of measure. Okay, unit of measure. So are we going to go with the traditional 5 foot 7 inches? Or are we going to go with 60 inches? You divide that up by 12 and you got a 5 foot tall person. You have to decide what you want to do with that. Now I'm going to show you 2 ways to do that. I'm going to again create a new sheet for height, and what we're going to need this time, if we're going to do feet, inches versus just a straight on inches, is we're going to need to do a random number, rand between, 5, 6. I mean, there are not very many 7 foot people out there or 4 foot people. So we're just going to do it between 5 and 6. And we're going to do it between rand between 0 and 11. I might say, Professor, why aren't we doing by 12? Well, once you hit that 12, you bump up a foot. And 0, you can have somebody that's exactly 6 feet tall. You don't ever call somebody 6 feet 12 inches. Okay? So now we've got our little system here. We're going to do it a little bit differently than we did over here. So this one, you got to think about what is 5 feet times 12, so 60, rand between 60. What is, let's go up to 7 feet, just shy. So 66, right? Just kidding. So that's going to be 72 plus 11, 83. Again, why didn't I go to 84? Well, I don't want to have an 8 foot tall person. Or sorry, 7 foot tall. So 7 times 12, 84. I don't want to have a 7 foot tall person in this data set. You might. I mean, heck, if you're making a data set about Harry Potter or some video game or some fictional world from a movie, maybe you have different heights. Maybe you're doing a Lord of the Rings data set or Game of Thrones. Okay, now that we have this set up, we are going to want to drag it down to the number of people that we have. Reason for that, if we don't do that, I'm going to show you what happens. We're going to do the equals height, and we're going to grab that one. And if we absolute cell reference that, drag down, we're going to have all 6s. Okay? Because at that moment in time when we pulled that number, it was 6. It doesn't randomly change each time. So what we need to do is, how many people do we have? 37. So we're going to go down to row 38. We'll just do this with all of it just so we have it. And you can go further. You're just not going to reference it. Okay, so there we go. We've got our numbers. So now we can go back to that formula we had. If you go to the top, and you can grab that, but then you got to think, okay, height. It doesn't say feet. So here's what we need to do with this. we're going to do what's called a concatenate formula. And you can do it here, or you can do it over here, and I recommend you do it over here. Feet and inches. Okay. So we're going to do a concatenate formula, which takes this number, comma, we'll put in a quotes, and then the symbol for feet, quotes, comma, grab this number, comma, quotes, and then the symbol for that, and Bob's your uncle, there we go. Now if you want a space in here, you simply put in a space. Or put in a space right here. Want a little bit of separation there. I don't actually know, shame on me for not investigating this, what the actual nomenclature is. Over here, it's rather simple because we don't have to combine anything other than put in the quotes because we're dealing with inches. So now we have a choice. I prefer this one because your audience doesn't have to actually divide out by 12 to get a number. So we're just going to go over here now. Finally, we can actually reference our data. And go down there. And now we have a unique set of data. Now watch what happens when we change something. We have to copy paste special value this. Otherwise, it will keep changing on us as we construct the rest of our data set. Okay, so regarding the boarding schools, you might have to hunt for a while to find the right information that you need. But we're going to grab all of this data, everything we can, all the way down. Now, one problem I see here is we got boys and girls, so some of our data might not mash up. So what I'm going to do when we get this data into Excel is I'm going to see if we can delete schools that are only male or only female. So we're going to bring it over, we're going to copy it again into a new sheet. We're going to paste special. Okay, so now we've got this. It is kind of messy, very messy indeed, because we have all of these images. We don't know what these check marks are. How do we get rid of this stuff? All that is going to be a great question. Okay, so the first thing that I want to do is I'm going to sort this so that I don't deal with this C, B, A kind of thing. I'm going to sort it by doing a function called length, L-E-N, because I believe in the nomenclature that anything that comes back as a 1 is going to be a letter, right? So we're going to sort this thing, not alphabetically, but by the 1 there. And my data does not have headers at this time. So there we go. We've got rid of all of this stuff. Just double check. Okay, good, good, good. Okay, so now here's what we're going to do. It's a little tricky. We don't need this anymore. We're going to do a couple things here. We're going to copy this a couple of times. Some of you have seen me do this in class before when you've asked after class. We are going to get rid of everything after the parentheses. Sorry, we're going to get rid of everything before the first parentheses. How do we do that? Up here, grab this little bit of text, including the space. Go to Find and Replace. We're going to go here and put in some asterisks, hit the Replace button. Now we've cleaned that up. We've gotten rid of everything after that parentheses. Now we have the school name. Over here, we're going to do the same thing, except now we're going to do a couple of things. We're going to get rid of everything after the parentheses. Whoops, go down there. Now we got rid of those check marks. Now we're going to do the same thing here, except now we're going to get rid of everything before the parentheses. Great, now we've got this stuff. Awesome. Now we've got that. Now we've got one problem. If we actually don't need this anymore, but now we have state and town, and I don't want that. Or, so I'm going to, there's a couple ways to do this. We could do the same technique. We could make a copy. I like to keep the original in case we ever mess up. That's why I'm copying twice. We could do this here where we take comma and space, full asterisks, and hit the replace button. So now we have the town. Over here, same thing, except now asterisks, comma, and it got rid of everything there except it left the space. So I'm going to do Control Z to reset, and I'm going to put a little space after that, comma. So now we don't have that space in between. Okay. Now, can you see any situations where this has messed up? Yes. Washington, D.C. It's a town, is it a state? So you have to make sure that you know what the nomenclatures are with your data set, okay? That you don't have extra spaces or too many spaces, or you have a town with multiple commas in it, stuff like that. You have to make sure that that's correct. So now we don't need this stuff here. And now, here's what's wonderful about this. We've got our boarding school. We've got our city. And we have our state. Now, I know some of this is Canadian, so do we go with the word territory? Do we go with the word province? You'll have to decide those things for yourself. I would say predominantly we have a lot of U.S. schools here, so your audience would probably prefer to see state and just go with the idea that we're also talking about that. So I'm going to bring this data over to our actual data set that we're working off of. I'm going to paste it in B because we need that random number generator to work. So we'll just put ID 1, 2, 3, not 4. Now we will have an equal chance of one of these schools showing up. Now, if you were to tell me, hey, professor, some of these schools have never been heard of, they're not very good, they're very small, well, then maybe we want to get rid of them. But maybe you're thinking, well, the Blue Ridge School, let's make sure that happens a few more times. So we're going to want to paste that down here like we've done with some of the other ones, right? We're going to bring that down. Don't know if my paste is working right now. Yep, okay. So we bring that down a few more times. What will happen with our data set is that Blue Ridge School will show up a little more. Now, if you're doing something more advanced where you want to study player performance, and you know that some of these schools are very good at performing, you might want to go back once you set up your data set to make sure that some of your players actually come from those schools. So if you want to make sure that Amanda Shell is phenomenal, you might want to put in the data set that she comes from Blue Ridge, Virginia, or whatnot, simply because you want to influence the data, and that's fine. You're making the data. You're the creator. So one thing I want to do here is hometown. So we'll put city, and this is boarding school, not high school. Now we can do some VLOOKUPs like we've done before. So we'll do a random. So how many rows of data do we have? Let's rename this to boarding school info. We've got 109 rows of data. So ran between 1 and 109. Grab this. And we're going to grab B, C, and D. That'll make sense in a minute. But we want row number, or column 2 for now. I totally forgot to use the VLOOKUP function. That's okay, I'd set it up anyways. Okay, so we've got all that. We're going to drag down, and now we have, actually we have this in the wrong area. That's simple enough. We grab the formula, We go over here, and now we have it. Over here, we're going to grab, what was the hometown in? 3. So now we're changing it to a 3 up here. By the way, I just showed you how to technically do multiple VLOOKUPs really fast. I simply do an A through D, knowing that this is B, this is C, and this is D. So I don't have to keep doing new VLOOKUPs. But I need to put a state in here. Shoot, didn't mean to delete that. State. Okay, and now we're going to do the same thing. We're going to grab all of this here, paste it over the 4, and now we have the state. If I were to just copy this over, we have problems because we never absolute cell reference those columns. Drag down. And actually, can you think of a flaw that we just introduced into the model? We just introduced a bunch of errors into the model. Can you think about that for a moment? What did we just do? Well, we just did random VLOOKUPs for city and state that are not going to jive with each other, and they're not going to jive with the boarding school. So what we really need to do is we need to go off of this over here, and that's really why I had this on the leftmost side when I constructed the data. So now we got 2 and 3. So we're going to go with a 2, bring this over, and we got a 3. Now these are solely based off of this stuff over here. Then we've got to ask ourselves, is Bishop's school in Quebec? Because we might have one more area that we have to fix. Yes. Well, Bishop's College, Lennoxville, Connecticut, Quebec. So we did this correctly. We can move on. Let's copy and paste this over. It looks like Pennington School got a couple of hits here, back to back. That's great to see, actually. Kind of introduced the idea of random chance, really. There's another Pennington right there. Pennington, Pennington, Pennington. Okay. That's really interesting to me, just how statistics work sometimes, right? We have 37 players and we have 109 schools. So we should have a 3% chance of any of them hitting. Or all of them hitting. So now you've got this established. This should be pretty easy for you. Let's just go ahead and put some majors. So this will get tricky because we don't want duplicate majors. So what we're going to have to do is construct this in a unique way or have a special if statement. Okay, so I want to talk a little bit about major 1 and major 2. So I created a list here of all of the majors for the St. Mary's University, all campuses, all different programs. For example, we have 3 accounting programs at St. Mary's, whether it's in Winona, Twin Cities, or Masters, 3 business intelligence programs, plus a business analytics, plus an artificial intelligence, plus a healthcare analytics down below. We also have different types of criminal justice programs, counseling programs, etc. So naturally, there's a greater chance that a student would have one of these based on a random pull. And that's exactly what happened here. We got a data analytics, got a data analytics, and a data analytics here. Now, people don't necessarily graduate from a Lasallian Honors Program, so you have to be careful when you get data from a data source to make sure it was built for your intention, or you have to clean it up yourself. So I'm just going to take accounting and replace that Lasallian Honors with accounting. Nobody graduates from that kind of program. Specialist doesn't make sense either, so we're just going to grab just a random poll here, health humanities. We'll just replace that specialist with health humanities. Okay. Now, regarding the second major, I did a random dice roll that said if this number is greater than this, then put in a second major. Since it's not very common to have second majors, I guess at St. Mary's it can be common, but in this data set, it randomly did not assign more than one here. Additionally, I had to make sure that the philosophy one was not the same as the management one, so I did an if statement to say if this equals this, put a 1 else a 0, and then find all the ones, delete them, and move on. Because I did have some of that stuff here, but I decided to go with mostly a single major environment. Now, age is going to be a tricky one. Why? Because we're dealing with hockey players here who often go on to juniors. So some of the hockey players, some of you in class, might not be the typical 18 to 22-year-old age group, despite being a freshman or a sophomore. On top of that, we do have an actual influence. Seniors are typically older than freshmen, so we can't just do a random number generator. We can't just do ran between 18 and 22 for multiple reasons. So what we're going to have to do here is we're going to have to devise something a little special. So what we're going to do, excuse me, junior, senior, okay? We're going to do the typical boring 18, 19, 20, 21. On top of that, we're going to add, if they were junior here, junior times 2, we're going to put a 2 here. And let's go with non-traditional here. What that means is if the student is non-traditional for some reason, took a gap year, didn't start college till 19, something along those lines, let's just add another thing here. These are going to be our base numbers, and then these are going to be our additions to those bases. Okay. So first of all, we're going to do 1, 2, 3, 4. Or actually, what we could do here is we could do a VLOOKUP for this, bring this back, and then do 1, 2, 3, 4. And what I'm going to do here is 5, 6, 7, 8, 9, 10, because I'm going to say traditional here. These are all traditional. So we're just putting a 0 here because these are going to be our modifiers. Okay, this stuff here is our modifiers. Now the word junior here and junior here mean two different things. This is our base. I'll show you how to do all this. So first things first, we're going to VLOOKUP the class against the class index we made here, grabbing the second column. Now I want to show you what happens. So that senior is 21 years old. Okay. Now what I want to do too is I want to put in a base here. So what that means is I am going to put in plus VLOOKUP of rand between, I already forgot what we did, so I'm just going to put 1 to 10 there. Rand between 1 and 10. Reference this here, 1, and grab the third column there. Now what will happen is if rand between, let's say the rand between becomes a 1, then it's going to add 1 to the base number that we've pulled. So we're actually doing 2 VLOOKUPs at the same time here to build one formula. So let's save that. For example, now we have a senior that is 22. Okay? We have a senior that's 21. We have a junior that's 22 years old because perhaps a junior did 2 years of junior league or another league, etc. So most of them hit this probability of between 4 and 10 being a 0. Okay. Okay, the next thing I want to look through is one thing I caution you on when you do work like this. You might have a great idea and then you put a bunch of stats up on the top, a bunch of variables, only to find out that your data set starts to take a certain shape. What I mean by that is we're talking about individual player stats. Does opponent matter? No, it doesn't, because we're not talking about individual games here. So opponent can be dropped. Now, score and points in this context are going to be the same thing as well. Okay. Now, A is not attempts, it's assists. Okay, how many times have you assisted? And where do we get some of that information from? Well, I put in a data dictionary here for assists. Awarded to the last two players who touch the puck before a teammate scores, provided no defender plays or possesses the puck in between. So the two players before teammate scores. Okay, so that's a very important distinction there. Okay, everybody, I want to talk more about these variables here. SH, shots, percentage on goal, plus or minus. Those are good. Minutes, power play. We have an SH here again. So this is an example of where maybe you pulled some data in, you had some initial ideas on how to get the data or pull data from your company, and you found some duplicates, or you want to avoid those duplicates, so just get rid of that. Keep looking through your data dictionary to see if there's something in here that you want to explore or don't want to. Empty net goals. So you want to make sure that with your data dictionary, it says the same thing. GW, winning goals. So as you can see, these are goal information, game winning goal. Game tying goals. Okay. HT. So those would be hat tricks. Keep in mind, you want your data dictionary to match up. So again, you can either change your data dictionary or you can change the variable name. At that time I chose to change the data dictionary. UA. Keep in mind with the hat trick thing, sometimes people think of the word hat. And so they'll use the full word because it's a 3-letter word. It's okay. Kind of thing there. So depending on your perspective and what you want to do with that. Okay, I don't have a UA here. So I don't remember what exactly that was. I'm not going to use it. I'm not going to struggle here. It probably had something to do with the MIAC League because my next variable over there is MIAC MVP. So instead of MIAC here, I'm going to put in like MVP, such as the count of MVP. So I'm going to go down to my data dictionary, put in MVP, most valuable player, and the number of times the player achieved the most valuable player award in a particular game. So what this means is it's not a yes or a no. How many times has that occurred? So that might be some good data to put in there as well. Now, the one thing I'll mention here is we don't have a lot of goalie data, right? All we have is age, games played, goals, attempts. You know, some of that stuff really doesn't apply to a goalie. So that's a situation where we have to think about it for a second. If we have goalies in the data, how useful is this data going to be when most of our players are not goalies? So do you want to put in some goalie information? Like, let's type in the word goaltender here or goaltender. See how many times that shows up. So it refers to the number of games in which goaltender did not allow a goal, so a shutout. So shots on goal refers to the number of times goals allowed per shot by a goaltender. So save percentage, kind of like in not a percentage, but kind of like Major League Baseball when you have closers. So this one might be a good one, SVS, just to put in there. Keep in mind, now we don't want, I kind of want MVP at the end here. So let's just put, what was it called again? Saves, yeah, that's what I thought, but SVS. So, okay, so there you go. Save your data, and now we've ran through it. So now we're going to have to assign those variables some information. Keep in mind that SVS should never apply to a goalie. So the first, or should always apply to a goalie. And so we're going to filter here and look for just goalies, or actually not goalies. At this time, we're just going to plug a bunch of zeros in there, okay, for saves. So 0. Just going to plug that in there. So now we have 0 saves for all these people that are not goalies. And when we open this back up, you will see that there are blanks here for the goalies. So now we can go through and put in some information for those goalies, which, by the way, now is a great time to see, did I mess up my data set? Holy cow, I've got goalies in here that have played 18 games and have got 0 goals. I've got, then they have assists. I've got a goalie in here that has played 8 games and has 6 goals. So now you've introduced some errors into your data set by having this broad stroke perspective. So what I'm going to do, for all intent and purposes, I'm going to wipe these out. Okay. Therefore, this would all get wiped out as well. So now we have goalies that have never scored a goal because they're goalies. And now we have to put in some save data. So you have to ask yourself, you have to do some research if you're not familiar with this, but how many times in a typical game does the other team do shots? And then you got to multiply that times 25. Because the goalie in this sense is receiving all of that activity from all of these other players here. Whereas before, one individual player could shoot and score 8 goals. Now the goalie is defending against possibly 8, 8, 8, 8, 8, 40, well, not the defensive, but maybe 24 goals at any, all the time in a game. How many shots are there against a goal? So it's going to be a lot more than 5, is what I'm saying, or 0. Well, it should never be 0. I think that'd be pretty impossible there. So again, you got to think about this in perspective of those relationships. Okay. Okay, so since we have a small subset of population, we can deal with them first, and go through that kind of stuff. But I'm going to leave this video here. I'm going to end the video because it should give you a good idea of how to do this. Obviously, this is a percentage, so you would have to put in a percentage there based on shots and goals. And power play, you make up that data, all those kinds of things here. Just make that data up. It's all numeric this time. There's not really any kind of concatenating or categorical data to bring over. No real formatting like this was. So I think you can take over this concept here and make your own data now. Okay?